Hello everyone. Here we will discuss about the traveling salesman algorithm using dynamic programming. Here the given graph is indicating the number of cities are represented in the form of vertices, and the distance between each city is represented in the form of edge cost. Okay, so here the traveling salesman will start from his hometown, for example 0. Then he has to visit all other branches, and then again he has to come back to his hometown. Here the condition is he has to visit only once all the cities. Okay, so once after visiting these cities, he has to come back to his hometown. So the traveling plan is indicated in the form of graph. Here the graph should have complete graph. Okay, so here the complete graph in the sense each city is having the connectivity to all other cities in his plan. So here 3 is having the travel route to 0, and also 2, and also here 1, right? So like that the 1 is also having the route, this yellow color arrows, to 0, to 2, and to 3. So like that each vertex, each city is having route, traveling route to all other cities. That is called complete graph. So here the graph can be directed graph or undirected graph, that is also there. So this one is directed graph because our arrow is having the direction to all the cities. Here the number of cities are represented in the form of 1 to n number of cities. Assume the starting city will be 1, and the distance between city I and the next city j is indicated by using a cost of I comma j, that is source city and destination city. Consider the subsets. S is having the remaining cities 2 to n. First city is considered as a starting city, then remaining cities are represented in the form of subset. Okay, so here the J notation is indicating the subset of unvisited cities. So here this subset is having unvisited cities in his travel plan. Let a graph of I comma s be the minimum distance when you are starting from the city I, and he has to visit all other unvisited cities. Then he has to finish his travel again at the starting city I. The first phase is calculated when the subset has only single unvisited city I. Then we can say the formula here, when the subset is having only single city, then the cost is calculating by using a graph of I comma s. Okay, so here I is the starting city and s is the subset. So subset is also having single city I. Okay, so in that case we can take Cij, cost between I to j, plus graph of I comma, then once we visited that city I, then there is nothing available unvisited cities. Okay, unvisited cities will be empty, so that's why we are indicating with pi symbol. Otherwise, if subset is having more number of cities, then we have to use the minimum of the unvisited cities is having more than one, then we have to take cost between I to j. Here we are taking I is the source city, j belongs to the unvisited cities, any one of the unvisited city, plus graph of j comma, this is unvisited city, selected unvisited city in this context. Then here total number of unvisited cities minus the selected unvisited city. So here we are going to subtract the number of unvisited cities minus this context selected unvisited city. Okay, the second phase, when s is having many unvisited cities like this, then we can calculate the cost between the uh, source vertex and unvisited cities equal to j belongs to 2 to n. So here we are going to take minimum cost value between this unvisited cities. Okay, so now the tour has to be completed after visiting all n number of cities. Then we have to calculate minimum distance between the all routes. So based upon this representation, so this representation is same as here, which is given here. Okay, so this one, and the city here j is representing here nn, that is the thing. So now we are having the problem statement with the four number of cities. The four number of cities has to be visited. Here the source city, starting city is here 0. Then here as I said, yeah, this graph is the complete graph. Okay, then only we can apply the traveling salesman algorithm using dynamic programming. Okay, so from this graph, for computer programming, we are going to construct adjacency matrix. So here the adjacency matrix, the number of vertices given in the row and same number of vertices given in the column. So for example, 3 to 2, when you are taking this, the edge cost is here 8. So 3 to 2 edge cost is 8. So 3 is the row and 2 is the destination column. So like that we are representing the adjacency matrix. After that, now we are starting the travel from I equal to 0. So I is starting city, and S is having now subset of unvisited cities. As of now, unvisited cities are 1, 2 and 3. So here for calculating the cost, we are having the formula graph of I comma s. I is the source city and s is unvisited subset of vertices, that means unvisited cities. So here we have to calculate the minimum cost between the unvisited cities from source. So here that formula is given, I have explained in the previous slide. So now when you are starting from city 0, I is 0. Now when you have to substitute the values here, and s is having 3 unvisited cities, so count of unvisited cities is now 3. Then here we are going to substitute the value I equal to 0, then s is 1 to 3 here, and minimum of j belongs to 1 to 3. So here j belongs to s 1 to 3. Now here I am taking among this 3 cities, unvisited cities, I am selecting initially 1. So here I is 0 and j is 1, then plus g of here j is here selected as 1, then unvisited cities here s is 1 to 3, then minus the j selected here is 1. So 1 is given here. Then I am selecting second city. Okay, so second after this I am selecting second option, so 1 2. So when I am selecting 2, so I is 0, j is now 2, then plus g of j is here 2, then s is here 1 2 3, already we have mentioned here, and here the j is selected as a 2. So now here second option is also completed. Third option, right here 0 to 3. So this option, so for when you are selecting 3 as a option, now we have to check cost from I to j. I is 0 and j is here 3, then plus graph of j is here 3 and s. Okay, s is here 1 to 3, we are already we are defined here, then minus now selection of city is here third city, so that's what j here. So from this when you are calculating, you see when you are subtracting this 1 to 3, right, 1 to 3 minus 1, you will get 2 comma 3. Okay, so 2 is subtracted. Likewise in this second option, when you are subtracting the 2 from 1 to 3, right, so you will get 1 comma 3, right. Likewise here when you are subtracting the 3 from this 1 to 3, you will get 1 comma 2. So now you see, based upon this we have to draw the graph, that means tree, it will be easy for our understanding purpose. So based upon that, here I am drawing c 0 to 1, so that is 0 to 1 I have drawn. Then here 0 to 2 I have drawn 0 to 2. Here 0 to 3, third option, here I have drawn 0 to 3. So based upon that, now we have to write this option. Okay, the option here 2 to 3, right, and 1 to 3, right, remaining. So you look at that, when you are having c of 0 1, we are having the option g of 1 1 comma 2 2 3, right, subset. So that we are going to write here. So here we are having g of 1 comma 2 of subset is 2 comma 3, right, this first option. Like that, second option, here we will have 1 comma 3, 1 here, and like that, here we will have unvisited nodes, here 1 comma 2. So first we will see the first option c of 0 1, right. So when you are selecting that g of, we have to, so this is one of the sub problem in dynamic programming. As of now we are segregating the given bigger problem into sub problems. So here one sub problem, here another sub problem, this is third sub problem. This is recursive call. You see the function g is calling again and again to calculate the values of sub problems. Okay, so it is a recursive call. So here first we are calculating g of 2 comma 3, so we have to substitute the values as per this formula, right. So here, which is having unvisited nodes, as of this unvisited nodes are 2 comma 3, so two options are there. When you're substituting the values, first I am selecting as a 2 as a j. So c I is here 1, then j is here 2, plus g of j is here 2 comma. Now you look at that, we are having two options. So, subset 2 comma 3, right, minus here j is 2. Okay, j is 2, so we are subtracting that j. So when you are subtracting this j, then you will get remaining 3. That's what this 3. Then another option is, here I am going to select 3 as a second option. Okay, so when you are selecting 3 is a second option, now here I is 1 and j is here 3, so 1 3 plus j is here 3. Then this 2 got from here, we are having two options. Okay, 2 comma 3, so minus here j is now 3, so minus 3. So now this is subtracted, so now we are getting 2, that 2 is given here. So now we got two options. So based upon the two options, for g of 1 comma subset 2 3, we will get two options. Okay, now the nodes are having two options. From the one, you may travel to second city or you may travel to third city. So here we are having two options. Like that, here now you are representing this option here, c12 2 comma 3, this one, c13 g of 3 comma 2, this one. Then you are at having you are at city number 2. Here also we have to calculate the value for g of 2 of 1 comma 3. So when you are calculating g of 2 of 1 comma 3, here you have to substitute the values. Here the subset is having 1 comma 3 j value. So initially we are taking j equal to 1, so c I is 2 here and j is here 1. Then here g of j value 1 and this 3 got from, we are having subset is 1 comma 3. Okay, right, 1 comma 3 minus here j is here value, right, this j is here 1, right. When you are subtracting this 1, you are getting remaining is 3, so that is this 3. After that, second value in the subset we are having here. Now uh, j is 3, so I is 2, right, j is 3, then here j is 3. This one we got from subset, we are having 1 comma 3, right, minus here j value is 3. So when you are subtracting 3, you are getting 1, that is this one, as per this formula. Okay, so now you are having two options, c 2 comma 1. So here 2 to 1. Okay, like that, here C2 to 3. So now we have got it. So now we are going to substitute these values in this node, right? So 3 is having this one, right? So now we are going to check another option in this 3. So 3, from 3 we are having the sub problem g of 3 comma 1 2. So when you are calculating g of 3 3 comma 1 2 subset, here you are having two unvisited cities. One is 1 and another one is 2. So now initially we are taking one is the j, so I is 3. Okay, I is 3, j is here 1 plus g of here j is 1. Then here s is here subset only. How we got this one? Because here we are having two options, right? 1 comma 2 minus, right? What is the j we have selected here? J selected here is 1, so minus 1. So 1, when you are subtracting this 1 from this one, then we are getting remaining 2, that is this 2 subset, right? Next option is here we are having j value 2. So now we are going to substitute j value 2, then plus g of j value 2 comma, here we are getting the subset result of this one. So how we got this? Already available subset is 1 comma 2 minus here j value is here 2. So when you are selecting 2, so 2 is subtracted from this 2, so now you got 1 as the result. So from this you are going to draw another plan from 3 3 to 1 and 3 to 2. So that's what 3 to 1 and 3 to 2. So now you are going to write these values, okay, these values into this position, this value into this position. So now we are writing that. Now again we are having one more sub problem from this level of the tree, right? So again I am starting from the left side. Here when you're starting from left side, this is the sub problem g of 2 comma 3. So when you're checking this, you are having unvisited node only 1. Okay, so no need to find out the minimum, because already we are having only one node is left with unvisited, right? So now j is here 3, so I j, the g of j is here. Now you look at that subset is having 3, so 3 minus, okay, subset is having 3 minus this j, so j is here 3. So 3 minus 3, it will be 0. 0 cannot be represented in the set, so we are going to represent as a empty set. That's why we are having here empty set. So here only one option, we are going to draw the next level of the node. After this, here we are going to select, right, next option. Here you are at the 3, you are having here only one option, that option is this sub problem. So we have to calculate here g of 3 comma, right, 3 comma subset is 2. So when you are having the subset is 2, you are having only one j value 2. Then here g of j2, you check this formula 2, and here you got empty set, because here you are having only one option 2 is the j value minus the j also now visited. If it is visited, then you have to subtract that. Okay, when you are subtracting that, you will get 0. That means set cannot be represented as 0, so we are going to represent with the empty set. So now from this you are going to represent this option here. So from the 3, so from 3 you are visiting node 2 you visited. So now we are going to write this value in this place, so that we are writing here. Okay, then next option, here you are planning from 1, right? So when you are planning from 1, here this is the sub problem g of 1 comma subset 3. Then here again we are having only one option 3. Then when you are having value c I j, j is 3, then g of j is 3. Then now as I told you earlier, here it is having only one option, that option is 3. So 3 minus that 3 also now visited, so minus 3, so you got the empty set 5. Okay, that's what here we are mentioning. So now as based upon that, here we are, I'm going to draw the next node here. 3 it is visited, then I'm going to write this value in this place I have written. Now next option is here 3, right? So from the 3 I am going to visit next node left as per this formula. So now 3 comma 1 here, once you visited that the j value here, j is 1, then we are representing g of j1. Then here when after visiting this one only 1 is there, so 1 minus here 1 as per this term. Okay, subset is 1, and also minus j is also here selected as 1, so 1 minus 1 you will get empty set. That's why this empty set is given. So after calculating this, I am going to draw this next level of the node, so 1 which is visited. Then I am writing this term here into this node. So that's what C31 plus g of 1 comma pi. Then next I am going to take this 1, and the node left as per this sub problem is 1 comma 2. So I am going to take that 1 comma 2 here. The 2 is the j value here, only one node unvisited in the subset, so j is here 2. Then here the 2 also visited, so as per this subset is having 2, minus j is also here 2, so 2 minus 2 you will get empty subset. So that's what we are getting here, empty. So now after this 2 is also visited, I am drawing that tree 2, then I am writing this entire term there. Okay, after this here I'm going to check the next option at the same level 2, right? So here this sub problem 2 comma 1, and when you are substituting the values, j is 1 here, then subset is having only one node, that is 1, that is this one. 1 minus j is here 1, so 1 minus 1 you are having empty subset, right? Based upon that I am drawing the next node here. 1 is visited, then I am writing this entire term here, C21 plus g of 1 comma pi. Now all the nodes visited, you look at that our graph is having only 4 nodes, 0 1 2 3. Okay, so here first level 0 visited, second level any one of the node from 1 to 3 visited, and second level also any one of the node visited, third level also any one of the node visited. So after visiting all the nodes, he has to come back to his hometown. Okay, he has to come back to his hometown, so every node he will come back to 0. Here also after visiting 2 come back to 0. Here also he will come back to 0. If he selected this route, from here he has to come back to 0. If he selected this route, he has to come back to 0. If he selected this route, he has to come back to 0. So to represent like this, it is looking like clumsy, so it is making confusion. So I am going to use 0 here itself. Okay, that is the starting vertex. So from 3 he is going to visit the starting vertex, I will represent here itself. So based upon that, from left side I am taking, so this is the calculation. From this calculation I am going to apply here 3 comma pi. Okay, so when you're applying the 3 comma pi, nothing is unvisited, that means he has to visit 0. So I am directly drawing the 0 here, it is given like that. All other nodes, okay, all other nodes I am going I am drawing, he is going back to hometown, that is the starting vertex, right? So now we have constructed the values by using all these steps. These steps has to be entered in the table. Okay, dynamic programming is following the table. So after that we have to use bottom up approach. Okay, bottom up approach. Using the bottom up approach, so we have to select first number of unvisited nodes are here 0. So where it is 0, here the number of unvisited nodes are 0. Then second, here from the bottom to up, second level, here unvisited nodes are 1. All the levels you see number of unvisited nodes are only 1. Okay, like that when you're going again next level from the bottom, here number of unvisited nodes are 2. Finally here number of unvisited nodes are 3. So like that, here from the bottom to top, we have to calculate the values for each sub problem sequentially. From the sequence of decisions, we will get the final optimal solution. So that we are going to do now. So based upon that, first we have to write the nodes, values, okay, cost values from number of unvisited nodes equal to 0, that is empty. So based upon that, I am selecting here this s cardinality of s equal to number of unvisited nodes are empty, unvisited nodes are empty, right? So first I am taking g of 1 comma pi, then g of 2 comma pi. 1 comma pi already we have taken here, then 3 comma pi, okay, 3 comma pi. So based upon that, here how do we calculate this? So you use the adjacency matrix. G of 1 comma pi means here 0, right, source vertex. Okay, pi means here again he has to go back to source vertex. You look at that, from 1 to 0, right, 2 to 0, right, like that, 3 to 0, right. These are all again repeating, right. So 1 to 0, what is the value? 1 to 0, this is 2, so which is written here. 2 to again pi means 0, so that is 9. Then 3 to 0, that is 10. So now we have calculated, there is no other option, so all are calculated now. 3 comma 0, 10, right, 2 comma 0, 9, 1 comma 0 is 2. Then now we are going to calculate next level using the bottom up approach. Here number of unvisited nodes are 1, okay. So now I am going to use the same approach, bottom up approach. Number of unvisited nodes to be 1. So these are all values I am representing for our understanding purpose, okay. So these are calculated here in this one, okay. Then these values has to be calculated here. So this one is calculated by using this formula C21. What is the C21 here? You see, C21 is 6. Okay, C21 is 6. Here, C12, that is 7 here, right? Then C31, that is 4 here. C31, this one. Okay, like that, C13. So C13 is here, 3, right? That is given here. Then C32, so that is 32 is here, 8, that is given here, okay. So like that, here C23 is 12. So after that, we are applying the arithmetic calculation. You will get here 22, right. For the second node, here you are getting 17. For here this path 13, this path you are getting 6, right, here 16 and 8. So now for our convenient, I am going to use these values, and I'm going to update these values into this position. Okay, this is now 18. Okay, this value, okay, this value, right, based upon the formula. For this sub problem, this is the value. For this sub problem, this is the value. So 1 comma 2, so 1 comma 2, here you are getting 16, that is represented here, like that. Here for this sub problem, this is the value. So here that value is here 6. 3 comma 1 is 6. Like that, for this sub problem, this is the result. 1 comma 3 is here 13, right. For this sub problem, this is the result, that is 17, right. For this sub problem, this is the result 22, so that is represented here. So now we have calculated the values here, right. Then we have to check the number of unvisited nodes 2. Okay, the next level. So this level is calculated now. Okay, this level is calculated now. This is 8, this is 16, here, like that we have calculated, right. So now for that, right, you have to use bottom up approach, right. So you have to substitute the values of this C32 plus this value, right. So when you are calculating that values, you see, right, here I mentioned all the values which is drawn from the bottom. Okay, 16 here, this is drawn from the bottom, right. I like that I mentioned for all the sub problems. Then now we have to identify the values of C12. For C12, here what is the value? C12 here, 7. So 7 plus 22, 7 plus 22, it will be 29, right. So like that, you see 7 plus 22, right. Like that, C13 here, 3. Okay, so that is given here, right? And c 21 is here 6, so 21 is 6, right? C 23 is here 12, that value, right? C 31 is here 4, right? C 31 is here 4, we are taking from the adjacency matrix, right? Now C 32 is here 3 2 8, so 8 is taken here. So when you are applying the arithmetic calculation, you will get the values here, total cost, okay, at this location. So now from this you have to apply this formula, minimum of these up values, okay. So here 1 of 2 comma 3 is 20, you look at that, 1 of 2 comma 3, which one this is 1 of 2 comma 3, right? 1 of 2 comma 3 is minimum of these two values, okay. Minimum of two values is 20. Likewise, next one is g of 2 comma 1 3, this one. So minimum of this 19 and 18, so this one is 18, right? Next one is g of 3 comma 1 2, so minimum of 20 and 16, so that is 16. How we are selecting minimum? Based upon this formula, okay. Based upon this formula we are selecting these values, okay. So now we are selected these values. Based upon that, here 20 18 16, so now we are going to write these values 20 18 and 16. Then we are going to check the cost from 0 to 1, so 0 to 1 is 1, okay. So that's what given here. 0 to 2, 0 to 2 is here 15, so that's what given here. And 0 to 3, 0 to 3 is here 6, so that's what given here. Then apply the addition values. So when you're adding these values here, 21 33 and 22, so here again we are going to apply the minimum of these values. You see, this is the first formula we calculated in the first slide, minimum of 1 comma 2 comma 3, so this value, okay, this is the thing you look at here, right? So here when you're applying those that formula, you will get here minimum of, okay, this option, minimum this option, third option, so three values are there. Oh, this is 21, this is 33, this is 22, so minimum of these three values is 21. So our cost is here now 21 is the result, so that is the value we got it. So this is the final result of this traveling plan. He has to spend 21 units of amount to complete his travel plan. Thanks for watching.